Hello everyone. Hi. Um yeah, this is going to be a bit of a weird stream this time around. It's just me, at least for now. It's possible some other people may join us, but uh I think the idea for today's stream is we're going to have a look at some of the stuff that I've been working on outside of kind of work hours and looking at more like personal prototype stuff, explaining why this exists, how this exists, and maybe how to make something like this. And just kind of showing some things. Feeding off last week when we made a prototype. Well, at least when I began to make a prototype for this. But this marks exactly 1 week worth of progress. Since because I started beginning to work on this the last stream, which was last Thursday. So let's kind of jump into it, I guess. The first thing to note is that let's just kind of start about what this is. And then we'll get into why this is, and then we'll get into how this is. But just because it's a start stream, we'll get some time for some people to filter in and out. And I think we'll do that by just hanging around in this demo that I've built out of my at least current version of this, because it's still not finished. There's stuff that I want to add to it, and things I want to play with. But for now, I may as well show it off. Hello. This is a kind of a 3D to 2D prototype that I've been cooking up since last Thursday, which lets us take 3D models in Unity and pixelate them down so it's flat. So this isn't sprite stacking. This is full 3D objects that are being converted. So it is real 3D. In fact, I can prove it to you by by rotating the camera and showing you that it is full 3D, but with a lot of fun trickery going on behind the scenes. Now you can see my current poor excuse for water over here. It needs some work. There's an issue that I actually am struggling to understand why. I have it's so weird. I'll show this off later when we get into the actual engine, and I show you some things around. But there's something that is weird going on with the water shader. But we're getting ahead of ourselves. First of all, this is pretty cool. I'm happy with this. This whole thing started when we started talking, me, Matt, and Lydia, the three that make up Gilded Rune Games, the development company that this is being streamed from. We were talking about what we're going to do for our next game, and we're currently working on My Party Needs an Alchemist. It's going really well, really happy with it. But it's soon to be released in like a month or two, which means after that we have to think about what next and what do we do. And there's a long period where we kind of debate the next thing, because often it's quite a commitment. And for this, for the next game idea, we actually already have stuff lined up. But there's a chance that it changes if we have a really cool idea, before we get to that point. And our team, as I say, consists of 3 people. So we have me, who generally specializes in programming, and these days I do a lot of writing for story stuff. We have Matthew, who does programming as well. And then we have Lydia, who is our amazing digital artist, who does all of the art-related things and is wonderful at it. And she drew the little guy in the bottom right, and she does a bunch of things. We've released a few games for people who don't necessarily know our history. We've got 3 games out on Steam. The first game that we released on Steam was Boomerang Battles. That was a few years ago now. Then we released Lonely Path, which was kind of like a so Boomerang Battles was kind of like a 2D dungeon crawler. then there was Lonely Path, which was like a 2D puzzle game. And then Isle of Malagry, which was kind of like again, a 2D visual novel-esque a detective game with RPG elements. And then now, obviously, we're working on My Party Needs an Alchemist, which again is 2D. But you see a running theme here. All of our games are 2D, and that's because that's where our strengths lie. Programming for 2D is easier, and well, in most cases. And we don't have like someone who's been properly trained in 3D modeling and stuff. Everything that is there is just kind of like hobbyist level, right? Which is fine, but it means that like trying to make 3D stuff and like trying to like push towards 3D is kind of a bit of a challenge and a bit tricky because it's a lot to commit to, So what it basically means is for us to ever like try and go into 3D, which is something that we want to do, it means we need to make a bunch of prototypes and things outside of like the scope of the project that we're currently working on to justify that it is doable and that it can be scaled up to make a full project. And so that's where weird stuff like this comes in. I tend to make a bunch of prototypes randomly throughout the year as just as like because I like to do that, and occasionally I have a weird urge to go and make a thing. And this is one of those urges that have panned out, I think, particularly well. It started when I was looking at some posts and things, and I saw somebody's work that really inspired me. Hang on. I have this, which we'll get to later. That's just some documents. But this is the work of someone called Tessellator, with a 3 and an 8. They made this this post that showed off this pixel art 3D rendering in Unity. It looked really, really good. I saw it and immediately it was like, wow, that's really cool. But they also kind of showed off how like it had like these 3D rendering elements, and I was just blown away by this. And I was like, how do you do this? That seems really neat because we love pixel art. We think it's really cool. This just seemed to be like really powerful. And in game development and other things, there's quite a lot of different specialities for all kinds of bits and bobs. But for this kind of thing, like it's all kind of got a lot of like tech art related stuff. So this is messing with shaders and render pipelines and all of that kind of funky stuff. And I don't really have too much experience in that either. I've as part of my university course, I did a bunch of stuff with DirectX, and that did involve learning how, and fundamentally understanding how, to render 3D objects and how shaders and stuff contribute to that process. But beyond that, I hadn't really looked too deeply into it. But in recent projects and prototypes and random things that I've been working on, I found myself touching more and more on this kind of stuff. So I decided I would try and learn as much as I could from this process, because shaders are really cool. And often, a lot of stuff that I would pre-program could be done way simpler in a shader. And I don't know. I just thought that was a really cool thing. And they kind of show off their 3D stuff, and then they go through this whole process of putting together the scene, and they give some kind of explanations, and they show off some things. And we'll come back to this, because this is a really useful diagram of showing how things work. But with a lot of this stuff, it's mainly just guides of people showing you the fundamental concepts, and they never really explain how to make it beyond overviews. And I thought maybe I could help out and be a little bit more explicit in how some things work, and then how to automate things, because there's there's the visual style of how this all looks, which is one element, but then there's also how do you do grass? How do you do grass without 1 FPS problems? How do you instantiate that? How do you get that all to work? And then all of the other bits and pieces, like how do we get the shadows to function, and all of these bits and bobs. And how do we get the terrain and stuff to work? There's so many things to touch on. So I started out with just kind of running at the problem and seeing how to do this. And thankfully these days, finding tutorials and things and learning through just like random online resources has never been easier. So I opened an Obsidian vault, made some notes, and started gathering references on what I wanted to do. And this is a list of stuff that I have looked at in the course of creating everything you see here. Basically, these are all of my references of how to get from where we are. Starting with the inspirations, and then moving into like explicitly how to make the stuff that we're at. So David Holland is another person who made stuff specifically for the Godot engine, or Godot, depending on how, or Godot, depending on how you pronounce this. And they wrote this great article that goes through their inspiration. They were also inspired by Tessellator, and they go through their process and how they achieved similar looking results. And they explain some of the kind of more tricky things that people don't really tend to think about. Like, for example, how do you stop like the jittering of pixels on screen with movement? And they explain this problem. So the idea is that actually we'll wait a little bit to get to the theory, but they show off some of the things that they made and how they made it for that. And I really like their water. It's way better than my current implementation. So I will almost certainly come back and pinch some of this and see if I can make something cool out of it. They have cool rain and stuff. Oh, that's so neat. I want to make that. But that's the idea. So I've kind of broken this down into various steps on how to produce this. So let's jump out of the demo and get into the editor, and we'll talk about like what those kind of various steps are, because I think it's worth kind of breaking it down. I also haven't really got too much prepared. I mean, I have like all of my resources, but I haven't got like a step by step on how I'm doing this. So if it sounds like I'm going, just riffing on, it's because I am. But that's. I'm sure this will be. It's not going to be super concise, so I apologize in advance. But yeah, actually, before we jump out, then I'll just go over the basic steps. So the first thing that obviously you want to do is pixelize the screen, and this is actually the easiest step I think out of all of it. Then outlines, getting outlines to like help define stuff. You can see actually in the scene, this cube here that I'm bumping into now has been left like unmodified, so it has no outlines. It doesn't get touched by any of the shadows or anything. And with everything looking like this, it all blurs into each other too much, and it's really hard to get definitive definition in shapes. So like if you imagine these cubes without any outlines, you would effectively have a grey rectangle with two darker colors, here and here, and you'd lose the rest of the shape. Whereas when you have those outlines, you can actually just read the silhouette and figure things out. Same with this cow over here. Like you can see that these lighter inner edges help you give more definition of like the curvature of the body, or at least the shape of it, so that it makes more sense when, for example, you rotate and the silhouette changes. It's just context that helps the eye, and I think it really makes quite a big difference, especially when you have things like a bush, and like these outer edges like help give a definition of like the depth of the scene. So after you have the outlines and the the pixelation of stuff, If you've got that going, then you're in a pretty good place. From there, it's just like fancy things that you can optionally do or skip. But I will preface that I actually failed those 2 steps. I got pretty close, but I ended up basically paying for somebody else's solution for pixel perfect outlines, and I'll explain why I did that, and I'll show the rest of it as well, and like my initial implementation and why I failed. So because this has been a learning experience for me, and we'll get into it, okay? So pixelation and stuff. If we jump out of here now and we go into our actual test environment, you'll notice that this is what the actual scene looks like in 3D, right? It's pretty, like simple stuff. I mean, like for example, our bush is just a rock that's effectively painted green. We have this nice 3D modeled house. You can see it's got a bunch of like lighting and weird artifacts and stuff going on. And same with this tree here. You can kind of see that there's some weird things. This is just because we didn't make the trees well and the house well. This is very quickly made 3D modeling with little experience, and I think my lighting settings are probably wrong as well. But this is all fixable stuff, right? This is just for testing. We have the basic pillars and things, because on every single like example reference I've seen of people trying to mimic Tessellator's style, this pillar is there. So I thought, you know what, I'll make my own Tessellator pillar. And so yeah, that's the idea. So to pixelate this down, like the standard method is pretty simple. You in Unity have, depending on the pipeline you use, so we use the Universal Render Pipeline, or URP, you will have a these like render pipeline assets that allow you to control the way that your allow you to control the way that your like renderer is going to kind of draw things, and there's a few important things that you'll need to do for this to work. So once you've got one of these like created, a normal like URP pipeline, you'll start with a folder of various quality settings. Because there'll be variants of each of these pipelines for different qualities. So when you're changing the lighting qualities, it's often that you're effectively choosing which of these profiles is selected and given to your renderer to actually like draw stuff. The rendering pipelines themselves will control whether or not you have opaque masks, whether or not you'll have these depth textures. You'll definitely need depth for this to work. You'll notice that right now this camera is in perspective. Like you can see up here, persp. When things are rendered out in scene, obviously we're using an orthographic camera. This is kind of important for a few reasons. One, I think that looks better. But two, it will be useful later when finding outlines and stopping like distortion in pixels when you move around. So it's important that you have that kind of setup. Then the idea is that you can either go 2 routes. You can pixelate per object, which is great for hybrid styles. So for example, if you have like 3D meshes and models, and then you have like you want to have pixelated sprites and things all together in one scene. But personally, I'm not so much of a fan of hybrid styles, and so I went for the more traditional method, which is pixelating the entire screen and having having everything be 3D pixelated down and then upscaled. And to do that, it's surprisingly simple. You make a render target effectively within the like a render feature, which is it's a C# script that you can effectively whip up for Unity by inheriting its render feature and render pass classes, and then it's as simple as defining that like a resolution that is much smaller, writing the current screen down into that render target so it gets shrink down and pixelated, and then scaling it back up again. So you're drawing up that pixelated version back to the desired screen size that you have, right? And that way you end up with really nice pixelated scenes, and you also get the performance benefit of having a naturally very small render size, right? So your actual screen is really small. It's just being drawn to be much larger, but all of the lighting calculations and things are going to be ideally going on when things are small. So then after that is the hard part, outlines. So when things are at the state where it's small on a render target, you now need to figure out how to outline stuff, and that is not particularly easy. So by the way, for that first step, if you yourself wish to create this, I would really recommend What Eeps or Mali Makes YouTube video on the subject. If you look it up, pixelated rendering in URP. I think its actual video name is Unity Pixelated Rendering in URP using Custom Render Features Code Walkthrough. And it is exactly that. It is just a really nice tutorial that goes through and it shows that. That's what I did for my initial implementation. And if you want to see what my initial stuff looked like, I can go and find a picture of it. It's basically what we have now, but without the outlines. So I'll quickly look, but if it is not easily visible in a few seconds, then you'll have to take my word for it, that it was just like now, but with no outlines. Yes, here you go. I have found it. Let's pull this up on screen. So here you can see the house asset that Lydia 3D modeled. You can see that it is being pixelated by this render pass, and you can see that it is basically just been crunched down, and it's nice and pixelated, but without any of the outlines. And you have quite a lot of control with the render pass like this, because obviously controlling the resolution is going to determine how many pixels that you actually have. And so you can make things as chunky or not chunky as you desire, effectively. And even this looks nice, in my opinion. I think this is still it's still nice to get, like, I don't know, this kind of thing. I don't know why I like it. I just think it's cool. But outlines make a huge difference in the long term, especially when you apply motion to the scene. Everything kind of gets a bit challenging. So at this point, like, stills are great, but moving, I don't have like the camera. It doesn't account for these like filtering issues. So the idea is that when you're moving around, the way that the screen samples pixels and then basically represents that on your screen pixels are they're not like the same grids. So it's possible for it to like sample like halfway between two pixels, and then you get these very strange artifacts that appear that look really like blurry and messy. And there are tricks you can do with your camera to basically prevent this from happening at all by making sure things stay on, like that these grids are aligned and that kind of thing. And there's some great videos, actually one by Teslator, that explains at least methods on how to make that scaling better, but also there are tutorials on how to make those kind of cameras. David Holland's article, actually, which is just 3D pixel art rendering, if you Google that, it'll be probably the top thing. That has an excellent thing for their solution in the Godot engine, and it's transferable into Unity's side pretty much. There was also somebody else who made a really good version of this, which was Cody J. King, and they made a a little project that is open source on GitHub called Hello3JS, and it is it has a little video. We can look at it now. Basically, it is just exactly what you'd want, right? It's a pixelated 3D scene with the outlines, right? Perfect. And they have an excellent article written by Omar Shihata, I hope I'm not mispronouncing that, which goes over the general process for outlines, and we're going to have a look at it as well. So it talks about Obradin and you know, how having fun render passes is cool, which I agree with. And then it goes through the basics of the shader. So the idea is you're going to need the depth buffer, the normal buffer, and then you need the color of the original scene to overlay, right? And it just steps through the process. But does it have any fun photos? No. Okay, hold on then. Let's get some visual aids. This is this. I love this GIF because it. Wait, wrong GIF. Hang on. This one, because it shows you every like kind of part of the process, right? So you start off with your colors, right? This is just the standard scene without anything. It's just pixelated, right? So we've already got that step. The next thing that you need to do is gain access to the depth buffer. So the depth buffer is a thing that is extremely useful, and as you can think of it as a texture that is lighter the closer you are to the camera, and then it gets darker the further away an object is. Sometimes, depending on funky things and camera settings, it can be flipped, so it's darker and then it gets lighter the further away you are. But it's super useful, for this progress, because outlines are hard. Like, humans are really good at outlines. You can just kind of look at a thing and then point and go, yep, that's the edge of it. But in shaders, you generally are given basically a pixel coordinate, and everything for color and things like that are determined, based on what the current color of that pixel is. A few other bits of information, but you have to then determine, is this an outline pixel or not? And by sampling the neighbors of the pixel around it, we can get some information. But other than that, you don't have much to go on. So the depth pass is one of those things that you want to be sampling, right? So if you know where you are on the depth pass, you can look at the colors around it, and if over a certain threshold there is a difference in color, you can kind of get an idea on whether or not you're at the edge of an object, right? So you can see like this grey cube in the middle is like this one, like the whole object is the kind of the same color roughly, and then so it's not going to say like inside is a different color if you sample it. But then when you get to these edges, if you were to sample the pixels around this point, then you can easily tell that, oh wait, there's an issue. And then different methods handle it differently, but you can some people count how many pixels are different and then mark that as like a hard outline, and then some will be like, if there's not enough, will be like a weak outline, and then you basically check if you have enough strong and weak ones to determine whether that is an outline. And for more knowledge on that, you can look up Sobel outline shaders. They're pretty interesting, but not what we use for this. But that's generally for like outlining objects on a static image, which is way harder because you don't have cool things like depth passes to depth buffers to give you the cheaty information you need to easily find your outlines. So then that's great. That gives us our outer outlines if we can sample those. Nice. But what that doesn't do is give us our inner edges, and for that we want normals. Normals are pretty cool and are very, very important for all kinds of things. Generally, when people talk about normal maps and things like that, it's referring to lighting, right? So what's really, really useful about these is that so when you make a mesh, it obviously has the kind of the vertices and how they connect together. So you have that, but you also get the normals that come along with it. Which are basically telling you the direction that faces are. Basically you get a bunch of vectors and they show you the face that is like the 90-degree angle off of that face, basically the way that it's facing. So you can know whether or not a plane, for example, is facing you or facing away from you, because most planes are rendered one-sided. So that information is really important because it's the difference between whether or not you render anything and if you just get like an invisible face looking towards you, which would be very bad for obvious reasons. And the way that data is represented is by the color of the faces. So you can see that any face that is pointing, is angled at this direction will be colored pink. And you can see that all of the instances where it's this color is when faces are angled in this way. And so what that means is that you end up with a situation where you can do the exact same thing that we did before with the depth buffer, but now we can check with the normal map and we can find inner edges now. And then that is super useful because, as you can see, you then end up with some information like this, right? So you have the two different types of outline. You've got your outer edge outlines, which are derived from the depth buffer. And then you have these red inner lines that are from the normal map. And then you just overlay them together, but you make sure that for my like the personalized style, and the one that I think Tessellator also uses, is you just darken the outer outlines so they're like low opacity effectively, but slightly dark. And then you lighten the inner edges so that they're, effectively a white with a low opacity. And then you end up with this, where you get these inner edges that are lighter and you can now like see things. And then you get these darker outlines that are darker and they help define the shapes. And you can kind of see how basically it makes everything so much clearer, right? And so that's the idea, like the theory of it. But to actually kind of implement this is a little tricky, right? So you, like with the tutorial I shared a second ago about how to pixelate stuff, that kind of gives you one full solution. They do have another video about how they do their outlines, but I think that this is where things got kind of tricky for me. I basically failed to get these outlines to be exactly pixel perfect, like 1 pixel outlines. You can see here that all of these pixels are nice and smooth, and what I ended up having was something that was a little bit more like this. This wasn't great. So obviously in my solution for outlining, I had a problem where, first of all, my outlines were not consistent. So you can see that there were places that were, I don't know, it just doesn't look good, right? This was after I fiddled with it for quite a bit, but the main issues and things that I was having with this outline is that one, separating the two of them and trying to get them to work nicely, I just couldn't get that to work. And second of all, because of the order in which I was doing my outlining, the kind of outlines weren't exactly pixel perfect, and I was missing bits, so I was getting like only partial outlines. Like you can kind of see on the roof here how like this edge doesn't quite have like all of the outline pixels, and that's because I was effectively outlining the 3D scene, then pixelating it, and in that I was losing it, whereas I needed to kind of do it on the already pixelated state before it was upscaled, right? So it is possible. You can figure this out. However, I kept doing more research and trying to figure some things out, and I eventually ended up on when I was looking through this Cody J King's thing. I was going through here, and they were talking about like this demo. And I know a few languages, but annoyingly, I do not know the language that this is written in, so it's not super useful. And even when I do, I'm not familiar enough with shaders to really get it to work. So I was kind of getting frustrated, and I didn't really want to stop here. But you can see that in the pinned links, there's a bunch of implementations of this. And so there's one by Godot, and then you can see the one that they've written in JavaScript. And then Unity's implementation is a paid one, which is called Pro Pixelizer. Now, before we get into Pro Pixelizer, which is eventually what I used, there are some interesting caveats because this doesn't do stuff the way that we want it to do. Mainly, it does it, and it stresses this. It is a per object pixelization. Okay, they actually have a. I'm not sure if it's even on here. But they have this article that they wrote, the person who made this, Elliot B256, which was pretty good actually, and it talks about how they handle kind of this per object rendering, and they use a really smart way to kind of make this work by effectively having a dithered version, and then they completely dither out the objects, and then they go and add pixels to fill it out afterwards, and this prevents the camera from having like weird sampling issues, and that means that you can have perfectly smooth transitions, and as if like it was pixelated as a 3D model, and like there was no interpolation at all, and that is cool. But again, for the style that we're going for, it wasn't what we wanted. So I tried it out, and I was a little sad because after realizing this, and I kind of feel a little bit stupid for buying it and then realizing it was this way around. After, by the way, reading the article on this, and then still deciding it was a good idea. Mainly because I wanted to like pay and have a look at the shader and see how it was done. Because again, just like this was for me at this point like mainly a learning experience. However, they have a Discord, and I went to the Discord, and in the Discord they have a private beta version, and in the beta version they have talked about how how they've added some basically they've added the option to go for the more classical method, probably because people asked for it a bunch. And so in my camera you can see that I use this full scene pixelization filter. And that is doing exactly what we've just talked about. But it also does a bunch of other smart things. So this camera basically eliminates the pixel creep issues, which is the weird artifacts. And I didn't have to program it, and that's nice. And I debated for ages whether or not I should just try and make it myself. But I just decided that probably it was only like 20 quid, and it wasn't really worth the time to figure that out when it was already kind of solved. So now we've got to the point where we have 3D objects and outlines. Amazing. But where do we go from here? So you can see, like, because that's useful, but it doesn't. Now we have to like make everything else, right? So we have to go and do grass and make the terrain and things. So for that to work, I'll explain a little bit about how the Pro Pixelizer stuff works. It has this shader graph in the 2.0 version, which is really, really cool. And basically, you apply these materials to, like, you have this like sub shader graph. You can make another shader that inherits from it, and then you can build your own shaders on top of it. And then you end up with this a shader. Then you can apply that to a material. Then you apply that material to the mesh, and then with its like a render pass on as well, everything just works, and it just saves so much time. It was amazing. I recommend it. But yes, so that's kind of where we're at. Now we want to do like some extra bits and bobs. So first of all, I changed like the outlining because the outlining colors and stuff were wrong. Not wrong, but like not the style I wanted. So I flipped some things about from the defaults. But it's effectively at this point it was kind of like finding my style out of the stuff that was there. Then we pixelated it obviously. Or where do we go next? Oh yeah, terrain. So this is a Unity terrain object. This is a thing that just kind of exists in general. What's really cool about terrain is that it can be, used as a tool for a bunch of things. It's part of the Unity stuff, so it's relatively well optimized. Yeah, we'll say it's optimized. Yeah. And it also has some handy features. So for example, I can like come over here and I can raise and lower the terrain with this brush, which is really cool. And I can also do some fancy stuff like paint away this texture, or if I want to, come and paint it back, right? And that's really cool because it means that we can really quickly 3D model a bunch of environments, and like a bunch of environmental assets. And then with the Unity terrain object, we can kind of shape it and draw stuff and do some really rapid iteration because we're again a small team of 3. And so if we're making larger scale projects or projects in 3D, we want, like, the main stress of this prototype in general is to prove that it's viable to do this quickly, because we've only got a very small amount of time. And in that time, we have to develop the game. We also have to market the game. We have to handle all of the other bits and pieces. And so it's really important that the pipeline is really clear and that, like, making this is really, simple, hopefully, but lets us have, like, stylistic and powerful results, right? The main issue I had is I wanted to generate my noise, like my grass, to be kind of like some of the references that I quite enjoyed. So if we go have a look at like Tesla's latest grass, you can see that they've got these big blotchy grass shadows, and these are really useful because if we look in the top right, for example, you can see that this is just a big block of green, right? And it's only on these spots here where the tones of the grass change, or when near a path, you actually get to see the definition of grass. And so I know that I needed to have some like stuff like that. So in order to do this, it's really easy. You just use noise. And so that is really nice. You can see if we zoom out, it's like in most things that use noise, if you zoom out far enough, it becomes very kind of easy to see repeating patterns and like see like a noise texture. So you can see that I effectively have like some noise, and then I have a few colors that I basically lut between these various values of noise. And if you're not familiar with what noise looks like, then I'll just jump into my little graph and show you. Where is ground? And all of this is done in shaded graph. And if there's any actual people who do shaders and graphics who are watching this, and they go, writing this in HLSL would be more efficient. I agree, but also I don't know HLSL, so shaded graphs are my friend. Okay, leave me alone. I'm trying to learn. I'll get there. But you can see. That where's the noise at? It's in here somewhere. Simple noise. Okay, so if we just remove these UVs for a second so that it stops freaking out, and we put the scale up a bunch, you can see that noise texture is effectively gradular, like values between, in this case, 0 and 1. And they have some, properties about them, right? So in this case, splotchy, somewhat random. They are technically deterministic, but for human eyes, you wouldn't be able to realistically predict what comes next. And they're super useful for a bunch of procedural stuff. So let's undo that so that my grass isn't broken. And yeah, so in this case, we're using it to make these blotches of green and dark green by taking that value between 0 and 1, and then using that to linearly interpolate between two colors. So basically, we want to kind of fade between two colors, but we need some threshold to determine how faded into one or the other is, and in that case, we're using the noise value, right? And by scaling it appropriately, we can get these nice blotchy bits. However, there's a problem. Default Unity terrain doesn't give you access to this. You can't just stick a material into the material. It doesn't let you do that, unfortunately. What it does, however, let you do is, as you can see, like combine these things together. And in the default Unity terrain, it actually does this by, just by, you can give it textures and have different textures. So that's cool. But to make it be able to handle that, we need to understand how Unity terrain works. And it's actually pretty cool. It uses something called splat mapping. And so if you imagine the terrain object as a giant square, it's a big square texture, and it has a bunch of other textures associated with it, right? So some of those textures are like height maps. So for example, you know how you can kind of raise terrain up and down. You see how like this bit is risen, that bit is lower. It's kind of like the noise map from before, where it's a big texture with values on each pixel between 0 and 1, and then you simply basically use that to determine your height, right? So where white or 1 is the maximum height, and black or 0 is the minimum height, and then by sampling the pixels in the height texture, you are able to get the you then offset the vertices by the that desired height, right? So that's how height maps work. How does it do different textures? Well, in a similar way, right? So you can think of it as with the splat maps, you have a texture map which is for how much where on the terrain the material or texture that you want it should be kind of rendered, right? And the idea is that you have 4 channels, so four textures that you can swap between on terrain. And the reason why it's 4 is because the values between 0 and 1, which are often used for between white and black, can actually be compressed down. You can fit that in, you can fit 4 of those into one texture by splitting it up into color channels. So in programming, and with light, there are the 4 primary colors: red, green, and blue. And those, how much red and how much between no red and full red can be represented as a number between 0 and 1. And so that is the exact same data structure that we have with the white and black. So you can have you can put one of those textures in just the red channel, then you have the green and the blue channel, obviously. But the 4th one is weird. It's not actually a color, but it's the alpha value. So it's the how transparent a thing is. And by having all of those into one color, we get our what's called like the control texture. So when we're painting on here, what we're actually doing is controlling, how red this part of the control texture is, and then when we swap over, you can basically set how blue a part of it is and how green it is, and then in its shader, in this big texture with it all together, it can pick the most prominent color, which one's sharpest, and then it displays the texture and stuff in that associated area when sampling it, right? That's the idea. And I can actually show this to you pretty well, I think, if we go back to the shader, and instead of basically putting these colors through, you can see that we have this here. If we just render the base color, then we'll get this really weird splat map, which just shows the channels. So you can see that the red is the grass, and by default everything is like fully red, and if there's no values at all, it defaults to red. And then you can see where I've gone and painted the green in, and you can see that it's almost pixelated on its own, and it does have some trailing between, so it's like it kind of almost transitions away. And the reason why it's kind of pixelated is it's based off the resolution of things. So the resolution of the image that it samples is how clean these outlines are. Now, a smart person wouldn't have made their terrain so absolutely massive when they started out, and then they could have shrunk it down to an appropriate size, and then they would have gotten a much higher resolution on this. But I was not one of those people, and so now I have to deal with a slightly lower resolution. But there is a bit of a problem here, which is normally not an issue. In 3D, when you're doing stuff and you're using these terrains, you want that gradient, right? So like if you have grass and then sand, for example, you want a natural fade from the grass to the sand, not just like a harsh cut. But if you have these natural gradients between materials in the pixelated 3D scenario, it looks really weird. because you shouldn't really have those gradients. It just doesn't look right. And so instead of smoothly, using these colors to sample it and having blends, in our test we simply use a comparison. So we take for example, the green, the green texture, and then we say, is the green, greater than 0.5? If it is, then we'll use the, like this dirt path texture. Otherwise, we'll use the grass. And I could use then like further comparisons with the blue and alpha channel to add 2 extra things here, right? So that's how that all works. And by simply like hijacking the the control texture variable under sort of control, we get this texture when we put this material into the shader settings. So it's really useful. And actually, there is more to it than that. You can go and get the normals and all of those bits and pieces. And I think in here there is probably a link to something. If they're not, there probably should be. There's a really great article that goes through and discusses this. I actually don't think it's in here. I'll go at it later. And then maybe I'll post those links in the Discord for people who are interested. But the idea is, there's a bunch of interesting variables and things that you can suppose. So for right now, we're just literally getting the control map, which is the colors. But if you wanted to put the textures and like normal maps and things, and in the individual like profiles that get given, those all have their own variables that you can hijack and use as well. So that can be quite fun. So once all of that is done, we can plug that in, and then boom, we have our terrain. Excellent. Excellent. We have our terrain back. Nice. And by thresholding it, we don't get the blur, the blend. We just get a harsh, like, is this or is this not the thing that we want, which is kind of ideal for us. And you can see that there's like these transitions things look a bit weird, but when it gets pixelated, it actually ends up looking really nice. Which is one of the reasons why I love this style. It's because it hides a lot of the mistakes and it promotes simpler geometry, which is good for people like me who aren't necessarily like super good at 3D modeling. But that's just you can do what you want with this, right? Next up, we can probably talk a bit about the shadows. So you'll notice that there are these kind of like these big blobs that go over everything. And it's weird that these shadows exist. You can see that moving here because there are no objects up in the sky, and there are a few ways you can affect the lighting in doing things like this. But the method I have chosen to currently go for is to effectively overlay a darker bit of shade using another noise texture, and then that material is applied to like a master material. It's applied here, this cloud overlay function that I've made, that just like you put in the cloud spin and scale, and then you multiply that together, and then everything those that darkens where the clouds are. And this is actually like a really important thing because all of our textures are procedural and they're being generated from noise. We get some huge benefits, and we actually solve a really, really tricky problem that I know some people have found tricky in the stuff when I was researching it, really, really simply as a result. So because everything is generated using noise to a degree, and by overlapping stuff, our cloud overlay, for example, because it's in a function, it works the same in all of the places where it's used. So we use it here in the terrain, and then we use it in the master material for the pixelated objects with the outlines. And because they're both exactly derived the same, even though they're calculated in different places, it looks as if the clouds and everything is just one effect, when actually it's different on the terrain and on the outline materials, which is, I think, pretty cool because it all just works. and you get some really pretty things. And I think this cloud also does a very different, a very good job at like highlighting the grass outlines. Now, I've gone for a much more gradiented color transitioning, just because I think it looked a little nicer than the more harsh ones. But again, that's a stylistic choice, and I might revert that if later on. But it's just it's very it's just like whether or not you posterize the noise afterwards. So you like break it up into like bands of color or not. But that's the idea for that. Now, let's talk a little bit about grass. We'll start a bit naively with the grass and just assuming that we're going to instance them as objects, and then later on we'll talk about GPU instancing and how we make the graphics card do a bunch of heavy lifting. Objects are expensive to do a bunch of calculations and things on in Unity. If you have hundreds and hundreds of objects, then it's pretty bad. In fact, with this stats window, we can see that we are batching 231 things, but we've saved by batching 13,380 things. And that's like our GPU optimization over here. That means we can rock around with a nice 400 FPS, which isn't the best metric for measuring performance, but you get the idea. It's very efficient and works nice. So the idea is then that, what is grass and how do we make it look good? Well, our grass is super simple. In fact, we don't really have to care too much about how nice our grass looks because it gets pixelated, and so we lose a lot of the details anyway, which means I can draw it and it'll still look nice. Which is, again, I love it so much. So it's such a useful perk of this. We start out with some simple 3D geometry. So we'll use a quad. And a quad is just effectively two triangles put together in a square. And then we will draw our texture to this quad. And, it'll just be like a simple texture. I think I have the original texture for my grass. Let's go find it. This is the beautiful grass texture that I used. I know, it's a work of art. But it's good enough, right? When it's pixelated, it's fine. This is my later improved version. Again, I know, so beautiful. But that's kind of the idea. You make some simple cutouts because we're not going to be necessarily needing to color this. We don't the reason why it's white is because we want the color of the grass to effectively be the color of the ground beneath it, right? Same with the all of the other foliage and stuff. We kind of want it to inherit the color from what's beneath it. Now there are a bunch of tricky things with sampling the color of terrain, and there's some people say online to have like a giant camera that renders the scene from the top down and show you, and then you can use that to raycast the color and do that. But that's an extra camera, so you're having to render the scene twice effectively. Some people talk about reading it from the the texture materials itself, which can be quite tricky again. But there is a much easier way, thankfully, because of the way that we've done our terrain generation in terms of its texture. We simply abuse noise. So we don't need to care about what the color of the terrain underneath it is, because we already know that if we just use the same noise generation method and it's seeded the same way, then it'll be the same color because of how we generate it. And importantly, when you see the noise, you are going to want to use some constant that is going to apply and change nicely and be have some consistency. And we simply use the X and Z coordinates. So if I were to go into my terrain right now whilst it's playing, and I were to grab the terrain object itself and move it, you will see that the noise itself won't change because it is not attached to the actual object itself, but it is derived, like the color of it is derived based on the position in the actual world it is. And because the grass is obviously above the location, and that in Unity the y-axis is above, it doesn't care. It's going to derive the same color as the position. Now you will notice, to break up the grass a little bit, that I have these patches of grass that are different colors, and that again is a pretty simple thing to do. You effectively have this this random chance in your grass to decide to be like a variant, and then you can just effectively flip your colors around, or cause it to sample a different color that will be in contrast to the original color, and that way you just get these graphs that pop. Now, in order to discover that randomness, you just have a really high scale noise, so that it's effectively just a random thing. Or in Unity's shader graph, you can actually there is just a random node that I found works way better, and then you just set the threshold. So on our grass material, we have I've created it in such a way, or is it where the grass has a chance. I have it at 93.4% chance of basically being the correct color, and then otherwise it will be the variation, like the odd colored version. And for now, that is how that works. Okay, next up is tricky. So we know how to render a quad of grass. Fine. We can create one quad of grass in the scene. Okay, but we now have the problem of how do we place lots of grass everywhere, especially on the terrain. That sounds tricky. Like on a mesh, that's not so bad, right? Because, for example, you can go online and we can go scroll down until we find the script for where is it? It is definitely here. Finding a random point on a mesh, and someone online has already written a nice script for that. Basically goes through and picks and gives you in world space the position, like a random point on one of the faces of the mesh, and by just basically sampling that, making 300 points on the mesh, you now have 300 positions where you can spawn your grass, or in this case, your foliage. I use a modified version of this script. The problem with this script is that it gives it to you in effectively mesh space, so then you have to transform it onto onto your materials. So it's extremely similar, but I have a bit at the end that translates it then, so that I can rotate and scale my objects, and it doesn't break. But you can see that's effectively how these trees work. I tell them pick a certain number of points, and then it will generate that many bits of foliage on them, and the foliage of the trees and the bush are very similar to the grass. The only thing that's different about them is how they are spawned. And for terrain, it's a little bit harder, because terrain you have to worry about a few things, like where can my grass actually spawn, and two, how do I know, for example, what height it is, and things like that. Thankfully, we know what color it is now, so we don't have to think about that problem. But height is a little bit more tricky, because obviously we want to be able to rise and lower terrain at a whim, and then press go, and then have our grass kind of be where it should be, kind of thing. And so to make it work, we can actually do a few things. There is a we talked before how there was a height map. Well, it turns out there's actually a really easy function we can use to extract that information. So when we hit go, we run a calculation, and we basically sample a bunch of points randomly in two-dimensional space. So technically we use this method called the oh gosh, what is it called? Precision disk sampling, I think it's called. Precision disk sampling. This, however you pronounce this, Precision disk sampling. There you go. What is Precision disk sampling, you might ask? Hopefully there's an image that really quickly explains this. I'll use this. This is a nice image. So imagine you get a bunch of points on a grid, right? You want to have some randomness, and it's just easy. Like you give it to, you have like a width and a height, and you just say make a random point at a random thing along the x-axis and a random point along the y-axis. Well, then the issue is that you get like a bunch of those points, but they're quite messy, right? So you can see random sampling here, and the disk sampling is on the right. And this gets us a much more uniform set of points. And the way that it effectively works is when it's generating stuff, it has like these radial constraints that it basically says when it's generating a point, it can't be near like a certain distance of another point. And it's a really clever algorithm. It's used to make really nice, pretty things. And so you might see precision disk sampling as a thing you can do in other places. But this is what this is in a simple form. There you can go onto the Wikipedia page for it. It's very easy to do this. There's also scripts out there already written in C#. I'm sure you can find that will basically just give you what you need for the sampling. It's very, very simple. That's not the engine. There you go. Then, once you have that sampling method, you now know where your grass is going to spawn. You have like a region where your grass is going to spawn, and then now you need to do two things. One, you need to cut out from those points that exist where your paths are, and two, you need to move them on the y-axis so that they sit at the correct height. The height one is easy. We can convert the world space coordinates of your points that you've generated into terrain space, which is like the effectively converting the XY world positions to coordinates on the height map, like pixel, like on the like the image of the pixels of that, right? And if you can convert those to terrain space, which is simple enough, you can just sample the height map at that pixel position, and then your world height that you need to place things at. So that solves that problem. And there is I think like sample height map function that just lets you plug in an x and a y, or in this case x and z value, and it gives you the required y world value out, which is really useful. So thank you, Unity, for randomly exposing that function, and no other way to access functions around it. I don't know why it's a little weird there, but yeah, it's a bit odd. Although actually I say that, but it's not true at all, because it also lets you get that control texture we talked about before. Do you remember with the splat mapping? I love splat mapping. What a wonderful term. If you can get the splat mapping texture, and you can basically just like when you're like analyzing a particular point and saying whether or not it should count as a place where you should spawn grass, all you need to do is say, does this position actually like, if we're saying that it needs to have a certain dominance, so like from one of the splat textures of 4, you assign one of those 4 to be a valid a valid splat index, we'll call it, and then what that means is you can basically say, is splat map 1 most like splat map texture 1 the most dominant? If it is, then it's valid as grass. If it's 2, which in my case is the dirt texture, then that's not valid, because I don't want grass on the dirt. And then once you can tell that, then you've solved all of your problems. You can now spawn grass in a nice random distribution, with accounting for the path, and you can also basically, yeah, and now it's also the right color as well. So you have your foliage. That's great, but you'll quickly realize that suddenly you will run into restraints. Like the game will really drop performance really bad. Before I explain how I fix that, I want to explain my initial implementation of the grass in terms of like how do we determine where grass spawns. So we effectively have these volumes, right? Before I had a brush that which is effectively the same volume that you would drag over a zone, and then I'd have an editor script, and you'd click place grass, and then it would within that zone run the like sampling, and you basically only get the points within that zone. Place the grass there, and then I also had a button that I could undo it, so you could basically go and stamp the grass down into the world, and it was nice. The problem though is that by adding a bunch of objects everywhere, Unity then has to calculate lighting, carry out physics. It does a bunch of extra stuff that really slows it down. So instead of doing that, we need to learn about GPU instancing. There are a few constraints on GPU instancing. It basically allows you to, instead of like drawing all of the individual meshes a bunch of times, this is very simplified, but you can do it once on the GPU really, really fast, and then copy and paste that information around a bunch, and you end up like skipping a bunch of computational time that it would to process that. The downsides is because it's cheating and it these meshes aren't real. I say in italics. They're not they're not truly like objects in the scene. You cannot do collision with them. You cannot easily send data to them because the CPU and GPU tend not to play well with each other. They must be the same mesh because you're copying and pasting them around a bunch, and they must use the same material. And so for our grass, thankfully, we don't really care about collision and stuff yet because we're not making our grass really respond. And we don't really need to because it's so low resolution that kind of detail is probably over the top. Though if you could, you'd have to use a compute buffer, but we're not going to talk about that because that's much harder. You could, we only have that one quad mesh for the grass, and the shader is doing all of the heavy lifting. It's one material that we're applying, and we are able to do a bunch of stuff like randomly select the basically the cutout of that, so basically the shape of it. And we're randomly selecting the color of it and determining all the color and all of that stuff all inside the shader, and because we've used noise to generate the grass and things, we can do that independent of any external knowledge. So the shader is completely isolated and we can pass it off to the GPU without ever having to touch it again, and that is glorious because it means we can go super fast in terms of processing. So basically it's really simple once you get to that point. In order to be as non-naive as possible, I moved on to these volumes, and the idea of these volumes are you place them in the world like this. I made a bunch of fancy stuff so that I can see things better when doing level design and things, but this is all just you don't need this really. You create your volume, put it into the world. Then we're now using disk sampling. I could just do random points and it'll be in a sphere, and then I can sample exactly how many points, but I'll never know exactly how many points I will get with disk sampling with my implementation of it, but I do know the minimum gap, so I set that. Then I need to know the height, so I need to give it the terrain. Then I give it the quad mesh, which I actually just use Unity's default quad mesh because it works fine. The grass material, obviously, and then I make it so that it spawns specifically on a splat index, and I tell it which splat index it should go on, which in our case is the 0th splat index, so the first one, so our grass. Then what I do on top of that is, because right now, obviously, our grass doesn't care about collision, doesn't know where any buildings or things are. We now need to be able to cut things out. So I have these void volumes, which I just slap into places where I don't want grass to spawn. Like, for example, here in the building, because that's probably a place where grass shouldn't go. And so I slap these in, and then I tell the volumes, the volumes that care which ones to look at. Then, when the game begins, what we do is we generate all of our points, and we filter through all of our conditions, like whether or not it's on the right splat map index, whether or not it's inside, one of these voids. We do that all in the first, start function, and then we save those points, we cache them, and we don't need to regenerate those every single, and do all of those calculations constantly this way. We just save all of those points. And then we can just, choose whether or not we want to use those points later. And by saving all of these points, we can update that and change how our grass works in real time if we need to. But obviously, each time we have to that's a lot of points and things to generate and do every frame. So we if we can, we only want to do that once. Then what we do is we simply go to the let's see. I have this GPU batcher code that basically we get a bunch of stuff, and the quintessential things here is we just simply draw the instance mesh, and oh boy, that's all it is. You just we have this list of matrix locations, 4x4 matrices, which are they're pretty simple to put together. They basically are just this 4x4 matrix is in essence what this transform is. It stores the position, the rotation, and the scale of the object, right? So you pass that in, so effectively you pass in all of your points and their rotations and their scales. You put in the mesh and then the material that they all are, and then the GPU just goes. But there's one small other problem, which is that there is a limit on how many things the GPU can batch at once. But that's easy. You just go through your points and split them up into groups. I think it's 1024, but I might be wrong. I know I personally batch groups of 1,000 at a time. But it might be worth checking, because often the GPU will do things faster in powers of 2. So you might be able to make it better if you give it batches in the sizes of powers of 2. But it might not. I don't know enough about shaders, but that would be my assumption. Powers of 2, generally a good thing. So yes, that is how you do that. And once you have that, you press play, and now you can see inside our grass volume, we generate a bunch of grass. So this grass it's not infinite, it doesn't go everywhere. We have design control where we can choose where our grass goes, and where it doesn't go, which I think is quite important for level design and things like that, having control over your abilities. And because it's all on the GPU, I can turn this and just tell it not to render, and then no grass anymore, and then turn it on, there's grass. Isn't it wonderful? But because the points are calculated at the start, if I were to, for example, move the void around, that isn't going to just start, eating the grass. If I turn the handle visible off, you can see the grass is still spawning there, even though the void is the void is there, because it only calculates that on the first frame. And so you'd need a button, or some GPU script, or some editor script, or some method that detects that the void is moved, to go update the point list if you wanted that thing to occur. But I don't really care for that right now, so that I'm completely happy with. So we've got grass, we've got outlines, we've got pixelized stuff, we've got the cameras and things because we cheated, but tutorials for that do exist. I'm just somewhat lazy, I suppose. We import Cinemachine for our camera angles. With an orthographic camera, it is a bit funky, but if you use just a virtual camera and play around with some settings, you can get it to look like this. And then one cylinder and a very very simple character controller later, you end up with this beautiful guy that walks in the direction, and then I've set it up so that when you press like Q and E, you can rotate the camera, and it currently just like loops it. But I would say that you know, like I'm probably going to like make some easing so that's more smooth, and maybe like let people like freely rotate it instead of using set rotations. That is kind of like where this is at, like camera wise. So for the foliage stuff here, of the way that this shades things is slightly different to the grass, but it's literally just we don't really need to care too much about lighting. We don't want really lighting on the grass. We want shadows to be able to go on the grass, but we don't want the grass to be able to themselves cast shadows. Whereas the same is not entirely true. Like, you know, we want it to be much more prominent on like the foliage, like on this tree, where it's like half of it is dark, half of it is light. So to do that, we just need to make sure that the normals and things are moving. Oh, actually, I forgot to completely mention this, but obviously you want the grass and things to always face you, and so you want to do billboard sprites, so they always face the camera. I'm going to share this because it's cool, but did you know you can do that in a shader? I mean, it's cool, it's really neat. For example, you can see, obviously you have a fragment shader, which is basically color and everything. You think of it as like the pixel shader where it draws the actual color and materials and all of that funky stuff. But the vertex is the actual like mesh, and so you can actually like fully deform objects and do fun things with this. But you can also rotate stuff. And so this subgraph, I'll leave it open so that people can recreate it should they wish. That's just billboard rotation right there. That you just plug that into your, you know, when you make your material, and boom, you got billboard rotation. Isn't that nice? I think it is. I think it's really cool. So there you go. So that's, I think, basically where I'm at. I mean, what am I missing? Do I have anything that I'm missing? I don't think so. We've got a movable character that can move around in the scene and rotate and stuff. We've got all of the stylized bits. We've got the grass. We've got the terrain. This water isn't really done, so I shouldn't really talk too much about it. This is pretty weird. Oh, that's not right. So we have an issue with the way that this works right now. So I'm currently trying to make a shader that is like a nice water shader, and it looks really weird because I'm still playing around with variables. But that has like foam edges that uses the depth mask. But for some reason, my shader, even though it works in the editor window, when we come back to it in the game, it doesn't work, and I'm not entirely sure why. All of my like googling so far is like people being like, "Hey, do you know in the pipeline you need to turn your depth texture on?" And yeah, I've done that. I did that. That was like step 1 because I needed the depth for outlines and things. So I don't know why it's not working, but almost certainly it's me being silly. So I will figure it out. That, or I'm already talking to like Elliot, the guy who's really great, by the way. Who made the pro pixelizer stuff. So hopefully, if it is something on that side, I'll find out and fix that. But I'll probably post a screenshot in the Discord when/if water works in the way I want. But I'm sure I'll figure it out. So yeah. The grass did used to look like hands, and they kind of still do. I do a few sneaky things, like for example, you can see how they're animated. Obviously, there's a thing in the shader graph called the flipbook, and you can pass it some textures. I pass it a texture array, which are kind of neat. They're just like a way to package up just a bunch of textures. And then I split them up kind of like a sprite sheet would inside the shader, and then based on some random noise I will choose which of the animations I want, and then animate them over time. I've been told that the grass and foliage stuff moves too quickly, like it's a bit too windy almost. I think I agree. There is, thankfully, just a single value, like a slider, I can turn down to make it slower or faster if I should wish. And if you're wondering where this cow and chicken came from, Lydia made those as well. I made the bushes and these little very complicated looking plinth, like stone things. Obviously, super complicated geometry, almost uncreatable actually. But the house and the cow and the chicken was Lydia. Weird, fun, odd facts that will curse this a little bit. The bush, the bush and the rock shared the same 3D model, which kind of makes sense, because it's like basically a bush is a rock but green and with foliage. But what is more cursed is that the little like orange like face indicator that helps you see which direction you're looking at is also the rock model but small and painted orange. So there you go. It's both a face, a rock, and a bush in this project, and you can get away with that because of the style, which I really am enjoying. So, what does this mean? Does this mean that the next game we're going to make is going to be a 3D game that uses this style? No, not really. It depends on if we choose that it's worth doing. But I hope it does because I really like it. But it's a team decision, and we'll basically decide based off all of the other candidates that we've got as well. We've been thinking about doing something that's multiplayer and networked. We want to do a fun team game, with like maybe just like optional or maybe like 4-player game. We're still like toying around. I don't want to say too much because I don't want to promise things, but that we end up not doing. But doing 3D stuff and networking stuff at the same time might be a bit ambitious. So we'll, because we've got experience doing networking and doing multiplayer things, but we haven't commercially made a game for Steam that has used it at like a larger scale. So that's kind of like a scary thing on its own. But maybe I add networking to this demo to prove it's still possible, or maybe we get crazy with it. Who knows? But yes, I also want to do like a dark night theme, because I have this really cool game idea that involves like having like kind of using light in interesting ways in a dark situation. So we'll play around with that a little bit. I also want to make a kind of like a world dissolving shader that like cuts away and makes like a weird spacey void, like chromatic aberration-y dissolve on the edges of the world thing at one point, kind of like a demo I made for a game a long time ago. So it looks kind of like you're on like not like you're on a flying island, but like that you're on a little like microcosm-y place. I think that's kind of cool. But we've got a bunch of ideas. We need to test and play around with 3D rigging and doing how we're going to make that work in this, and what style we're going to go for, because that is again stuff that we normally don't really have to touch in our pipeline, because you animate sprites very differently to the way that you animate 3D models, and so we'll need to test that. But I hope that we see a future where this gets turned into something more interesting. I know that like we've talked about maybe doing something that's no, actually I won't say that, but we've got we have some plans that we could potentially use this style for, and I'd love to see a game that's kind of either like Stardew Valley-esque or that's just something cool and 3D in this style. I don't know, I just love the style so much. I just want to find a really solid game that works with it. But the problem with Stardew is that is a big project if you went down that route. So there are other ideas that we're actually like more properly considering that that I think could be really cool. But if it turns out that is too much, we'll just probably go for like something that's equally stylized, but probably more on like a 2D setting, kind of like either something that's a lot more simpler, like Don't Starve style, where it's still kind of 3D, or we just go for an actual like top-down 2D like stylized thing that's closer to Boomerang Battles was. So that's kind of where we are at with that. But I really like this effect. I hope you guys like it as well. The water stuff is on its way. What else? I have like a... we can track my progress over here. And you can kind of see that, like, this is my, like, progression of where we're at. And at this point, I wanted to do water UI in a dark scene. And we're kind of getting closer to those things. UI should be really simple. I think I just have to throw like standard UI canvas with an overlay. Shouldn't affect anything at all. So that's easy. And a dark scene is just, relatively simple as well. I just want to test how lighting affects everything. And if it doesn't work, then I'll have to make some custom lighting solutions that I know exist. But that's, I don't know. That's where we're at. I just wish this foam worked. Like, I can see like little white dots as well, and I'm like, I think that's coming from the foam? It feels really weird. I don't know why it's so broken. Because, like, it feels so close to working. I almost just want to, like, jump into the actual material itself and just, like, move some sliders up and down and see if I can like get it to work, because that so this is all the normals. The foam color itself, if we leave it as white as visible, and that makes it darker, that makes it red, so that is foam, so it is there. So why are you... I make it negative or positive, it's just not working. And then the foam amount doesn't seem to change either. Or it's either like a negative, it's like fully foamed. And then like the moment I sip up, it goes down to like what it is here. And I have no idea why this is happening, so I'll have to like dive into this and debug this another time, but man. I think the water's gonna look so good. I'm thinking maybe like trying to get some like really nice like probe reflection. I was looking at getting like really like nice outlines and things, but the problem is that a lot of these examples are built for perspective cameras, and that doesn't really work super great in orthographic because you don't get the same. The orthographic camera perceives depth very differently to perspective. And most games use perspective cameras or perspective cameras. I don't know why that's tripping me up. But yeah, so but there are of course examples out there I can find. So it's just just taking the time to actually make it. But this is my progress in 1 week from last time. I've made all of this stuff. I've learned how to GPU instance. I've made and failed, and then bought and then modified and then built the shader stuff, outlines and things, and put all of this together. I hope you like it. If you've got questions or if you want to see certain things with it, feel free to ask in chat and I will do my best to answer it. But for now, I hope you guys like what you see. And I'm just gonna have a little walk around in the scene for a bit. I really love this shadow outline because I love it when it goes over like objects, because obviously it cares about because it cares about the XY position. It streaks across the entire thing, and with the orthographic view it really does give like a show of depth, and I think it looks great. Like if we look at the house and at this pillar, like when the shadow crosses over, you'll really get a sense of it and like how it you know, crosses over the complex shapes. So you can see it there with the pillar and on the house. I just think that looks so cool. Yeah, there you go on the cow. Yeah. So there you go. That's kind of that. I realised that my music's run out. Hold up. Where did I hide that? Over here. Nice. And I think that's kind of where we're at. This is what we've got. I want to get like maybe make it like a cool 3D character like that's picked up instead of just a cylinder. But you know, the cylinder does have some charm. I will say I didn't mean for this guy to look kind of like an Among Us character. I reused the, if you can kind of see in these pixels, there's a red crest and orange beak, and I couldn't be bothered to make new materials, so I just slapped the those two materials on, and then like when I showed people, they were like, Among Us, and that, yeah, and I was like, oh yeah, it even happened earlier this stream. But yeah, so I see that. But the guys, Among Us, they don't have orange visors. They have like silvery glass visors. It's like light blue. This is just red with a red cylinder with an orange like oval on it. You know, it's not Among Us. But you know, people will see what they see. Hang on. The Nightmare Chicken parts might be worse, actually. Well, it's not made out of chicken. It's just the same colouring as the chicken bits. Which is like, yeah, I guess it would be cursed if you imagine like a photoreal version. That would be extremely cursed. But try not to think of that. Try to put that out of your mind. But there you go. Oh man, I hope that wasn't too overly technical. I know like we've had a few people pop in and out during the stream. And we talked about how to make a bunch of stuff and just learning things, but I don't know if this was engaging at all. Maybe you just want maybe just showing this off at the start and being like, this is cool, would have been enough, and then we could have played Minecraft for a bit. But I don't know. What do people think? Was that interesting? Do you want more tutorial things? If I made more of this demo, would you want me to talk about it again, or are you like, is that enough? Was that a too much information kind of thing? That's weird. I think that's the light shining weird. Oh, not happening anymore. Okay, I will put that down as a bug. There's some weird, there it is. Something weird with the normals. Okay, we'll fix that. I actually think I know why that's happening. Oh well. There you go. I like it, but I'm very bad at shaders still. So it mostly went over my head. Okay. Yeah. Let's just make a shader. It's not that scary, right? So we'll jump into the scene. We'll use a perspective camera so that we don't go crazy. Let's just make a random shader with some noise, because that's probably like one of the more weird things, right? So create a cube or just like a plane, for example, right? A plane has obviously this lit material applied to it, and that is how it knows that it should be the color it is, that it should get brighter in the middle based off the sun, based off its smoothness. And it has all of these definitions. Making a material is super easy. If we go to our editor here, let's just like crack out like a quick shader. We'll just put it in the base so I can delete it easier later. And with URP, we use the shader graph. So we can go up to shader graph, URP, and then lit shader graph. And we'll call this example noise. And that will generate this thing here. When we double click that, we'll get something spooky. We get a little shader preview and window and all of this stuff. This is the less of the scary ways to do it. You can also just write into HLSL if you're a wizard. But this is like the much more beginner-friendly way of learning some of the concepts, right? So right now, we have a shader. This actually works. If we save the asset in the top left, and we come over here and we create a material, and we call this example noise material, then we can go up at the top here and see where it says shader pipeline lit. We can go look for our example noise, and huzzah, we've made a shader. We've associated it with a material, and then on the mesh we can either drag it here or drag it into the list here. And now this material is using our new shader, and it is using basically a lit shader because we haven't modified the shader graph at all, and so it basically looks identical. But coming in here, you can see we have two parts: the vertex and the fragment. For now, we'll just ignore this top one exists, and we'll just focus on the fragment because this is the the color and everything. Let's say that we want to edit and change a few things. Let's say that we want to control the color of an object, right? So we can come over here to this properties section and search for a color node. And we'll call this like example color, right? By clicking on it, we get its properties over here, and let's just say the default is red, and that its alpha is full. So we have red, and then we can drag this out, and this is example, and you see it as a 4. And what this means is that this is a float 4, or if you think of it another way, it is the red, green, blue, and alpha channel of a color, right? So if we just plug that into the base color, which is a float 3, so it's effectively it's going to drop the alpha value, so it's only going to be the color. And then if we come back into our scene, you'll see it will update and it will get this red lit material, right? Pretty basic. And if we go into the material itself, you can see that this example color is exposed, and we can just, edit our shader to our heart's content. And interesting things, if we were to create another material like this cube, and apply the noise material, and we go to the material itself and we change the color, it will update all materials. It won't instance them. There is a trick in C# that lets you, when you can set a material to an instance version of itself, and what that will do is it will allow you to use, you have two different things with the same material, but they could have different example colors at the same time, if that makes sense. But for this case, we're fine with just one thing. So even though our example color is purple in our shader graph, it will not know that, so it will still preview as red because that is the default color that we've given it. Excellent. So how do we, what have we got here? This is using the sub-target of lit. You can see there's a few other. I have the Pro Pixelizer one, which is the thing that I paid for effectively, to get the outlines and stuff. And that will change the target. But for most people that have lit, unlit, sprite lit, decal, and full screen. Full screen is cool. Full screen lets us do render passes. So let's say we want to make the screen more red, okay? So instead of just coming over here and then making material that makes one object red, we could, for example, say, hey, actually, this is a full screen thing now, and we are going to give it the example color. Actually, we're going to take the camera. Actually, we'll take the oh my gosh, I cannot remember the name of this node. I think it is it's not that. It's like let's just use the UV for now. Actually, why not? We'll just use the UV. So if we do that and we come over here, we'll see that our noise, so all of this suddenly has disappeared, and that's because full screen is not a material that makes sense for this, and so we can drop that from there and give it just a lit material for now. If you don't see a material, by the way, it's probably because it's default. So just click the eye in the top right, and it will become visible to you. So we can instead go make a fun render path. So if we go to our render path that does all of our stuff, which for me is this one, and we turn off the pixelizer stuff, we'll get some weird things going on there, but that's fine. Don't worry too much about that. What we can do is add a new render feature, and let's say that we want a full screen pass render feature, and then that is going to make all of the colors invert. But instead of full screen invert colors, we could put in our example one, and that is going to color our screen. We're now applying these normal colors to the entire screen. But yeah, so you can like put materials on the entire screen in this version of Unity by kind of going through that. Though you almost certainly want a nicer. This is a terrible shader. You'd want something better. I mean, you could cover the entire screen right with this, but that wouldn't really show much. Like something that would be better is if you got the base color, before effectively, which is a node. I just can't remember what it's called right now for some reason. And then just multiply this by a diluted version of this. You could kind of tint everything a certain color and do stuff like that. But to get noise, these exist, right? You can just go get some simple noise, and set your scale to a desired amount. Then we could just go get we could use this and multiply it by our example color, and now we have our kind of noisy colors. We'll set this back to being just a lit shader for now. Then we could if we wanted to add some panning and offsetting, we can go get access to time. That lets us this will be a float that goes up as the game time increases. So what we can do with that is we can make a UV a tiling and offset node, and we take the UV, which is just the top left to the bottom right of the object, and then instead of it just being still and static, we can offset it by time multiplied by some factor, right? So if we go get, for example, take that, make it an x, a vector 2 for the x and y coordinates of this offset, plug this into the UV, and we'll plug this into the UV, into the tiling, into the offset even, and then plug that into the UV. Then now you can see that we've got our noise texture scrolling, because we are constantly panning the texture positively on the x and y. So if you wanted to change the direction, you just invert these and control these more accurately, right? So only x will give you just sideways and so on, right? It's pretty cool. If you wanted to determine the speed of this, you just multiply this vector by some float, and it would slow down. And then, so you could then, control the size and scale of this, so you could make something along these lines. And then if we were to go preview that on this plane, then it's going to be like super laggy because it will only render in game. But if like when the frame updates, but if I hold right click when I'm panning around, you'll see it working. So this is, you can see an example of like some noise multiplied by some color on a plane as a shader. So that's pretty simple. But you can go quite far with like what possible with shaders. Like for example, like this is currently using the you can like add a sheen by like a stylistic sheen by like adding like some textures to it that like overlaid on top of this image and care about like the world's position on view. Like right now this cares on the UV, so it'll stay the same regardless of how like if it's scaled up, it'll scale up the noise as well, right? Because it's basing it off of like the UV, like the actual UVs of this, but of this mesh. But we could, instead of just using these UVs, we could go get, for example, the position of the world, and then this will give you the X, Y, and Z in the red, green, and blue channels. So if we make it a vector 2 out of just the X and the Z, so that we get a 2D thing, and then use these as our UV, then now once we apply this example noise, we suddenly get noise and stuff that is based off the world position. And if we move this around, it's kind of like a cutout, right? So because it's based off the world, so we can scale it up and down, and it's no longer based off of the plane but off of the world information. Now obviously we base it off the X and Y, so if we rotate it sideways, then we still see that it transforms stuff. And if we were to apply this to a cube, which we can do easily, then we will see that it's going to distort really weird on the sides, because you can see, because all of the information is on this like top-down view, you get just only like basically like a vertical slice like on these faces, and you can tweak that and change that by making the the shader a little smaller. But that's just a crash course on how you could make a weird shader. We come over here and make this not shiny at all by increasing the smoothness up. And now actually it's done the opposite. Man, did I tell you I was a beginner at this? I'm actually surprised though. Why is that the way it is? I'm not sure. You get the idea. Play with some settings. You'll make something that looks good. There you go. That's what I wanted. Now do it in code. Code is harder, but the way that you would do it in code, you would create a new shader, and you could get a standard surface shader, which is effectively a lit shader, and that will generate a HLSL thing, which is this. This will give you your properties. So this is effectively the properties panel of the shader graph. Then you have basically like these settings and things. So this is the equivalent of the panel on the top right. And some of this is a little bit more complicated. I don't know necessarily what all of this means, like pragma target 3. I don't know, you need to look up documentation for like all the different targets and stuff. This is the thing I find about like the shaded stuff. It's so like weird. I feel like you just have to know how it all works, and like you can't intuit anything, which is kind of sad. But it's just it's just very different from actual like C# programming. You just have to learn how it works. But the types and everything is somewhat fine. But this here is this surf function is short for surface, and you can manipulate stuff in code here to do the equivalent of what we were doing. So we could add we could use this color and remove it and modify it in some way to alter the shader when you make it a material. But this shader, new surface shader, is now like a material target. So you could come over and make a new material and target up here, like this. If I unpin this, there you go. This up here, you could go find that shader that we just created and you put it there. It's just the difference in how you do it. Shader graph is more easy to experiment and visualize, in my opinion, currently, but HLSL is more efficient and is cleaner. So yeah, crash course in Unity shadery stuff. There you go. There are a bunch of cool things you can do with it, like the wobble shaders and stuff that we use for our shorts, and things like that. Things that I made with shaders. But yeah, that's kind of that's that. I'll go clean up the project. But yeah, that's kind of a thing with shaders. Shaders are like one of those things where they're super scary to look at, especially the HSL part. But once you just kind of get over the initial impression of it, they can be quite simple, and there are a lot of resources where you can go and learn them. And then the more you learn of it, the less intimidating it gets, and then you can start making your own and making cool things. And then you'll go on Twitter and see someone does a breakdown, and then you'll like it and come back to it in 6 months and be like, yeah, I saved that crystal shader and now I can make a cool crystal. Which is what I do. But I think that's probably where we'll start to wrap up for today. I hope this was somewhat coherent. Again, I'm not primarily a tech artist. This is me just trying to learn and figure it out. But I'm quite happy with the end result of this so far, and I will continue to play around with it in my spare time when I can, because I think it's just so cool. It takes a while for them to click. But the HLSL stuff is tricky. Honestly, yeah. It's just I think a lot of the time it's because a lot of the shader tutorials and stuff don't go into the underlying principles of what the shaders are actually doing and why they're doing it. They just kind of show you stuff and how to do it, just drag these nodes here, etc. for shader graph tutorials. And that's not true for all of them by any means. A lot of the time, until you it's a lot harder to figure out how shaders work and why things are the way they are in shaders. If you just learn from the shader graph, with no other resources or experience. I'm not telling you to go play around in DirectX to learn shaders or anything like that, but you can having basic understanding of how meshes and things are rendered does help a lot. And then from there, honestly, I find with a lot of this stuff, the best way to learn it is to go and find either tutorials or older projects and then just dissect them, or find some content creators that create really cool shaders and give breakdowns, and then look through those. Reverse engineering I think is really useful, but you just have to find them, which can be tricky especially if you have a very particular shader in mind that you want to make. But I think I'm just messing around in Godot at the moment. Godot. I need to play around with Godot because I haven't played around with it since maybe for 6 years or something. It's been a long time. I played around with it, I think, at the very beginning of university time for me, which would have been Yeah, at least 6 or 7 years ago. So it's come a long way since then. Like, especially like during the whole Unity debacle. I mean, Unity literally fired like another 1,000 people yesterday. That was pretty rough. But yeah, more layoffs from them. That's always great. They're also like, they had this thing, they were making this like new pipeline that everyone was excited about, and they're just coming out and being like, maybe we won't do that. Maybe we'll just make stuff on mobile games and like making ads. Which is like, I don't know, not great. But, yeah. So maybe Godot could be a fun thing to look at, but it's just so hard for me because I've learned Unity and I feel comfortable in it, and like changing over to Godot now seems so tricky. And last time I was there, it was pretty bare bones. I think here's the thing: if I could jump over and I didn't have to learn GD scripts, I could just use C#, I'd be much more willing. But I'm less of a fan of like picking up something as niche as like it's like a domain specific language just for that engine, because it doesn't feel as transferable to me. So yeah, I don't know. I try and just like ignore everything going around the Unity controversy and just be like, it's fine. I'm like just gonna try and ignore it and make my games in my corner, and you can C# everything now, I think, in Godot. Whoa, well, if that's true, maybe one of these streams I can try and learn how the hell to use Godot, and we'll make something cool. I think its philosophy is somewhat similar, so hopefully it wouldn't be too hard to learn, pick up, but I'm sure it will take time to figure it out. But who knows? Maybe in the future we'll use it. But like the big issue is, like for us, we have this like huge library that we use of code that we've built up over like 3 games worth of like programming and things. So it's really hard to like, unless it's like, basically because we've built up our tools and things around Unity, it's so hard to move out of it without losing a bunch of progress. And when Unity does work and does everything we need it to do, like there's no real justification to warrant that. Although, just learning new tools is probably a good idea. So maybe I'll try it out. Yes, do that and teach me. Well, hey, you know what? If we do that, I'll let you know, and then we can learn Godot together. Is it Godot or Godot? Has anyone decided? Because Godot feels like that kind of works, but Godot I could live with that. I feel like I had more like extreme opinions about that at one point, but now I just want an engine that works, I don't know. Yeah, I don't think anybody does. So I think the best thing to do is to swap between it randomly, within sentences, and just be like, oh yeah, I love Godot, it's great. Godot offers me all of these new things, and that way no one can be, or either nobody can be angry or everybody can be angry, and then it's fair. But yeah, so we'll play around with it, have a go. I remember its physics and stuff being bad last time I used it, but that was, as I said, years and years ago, and I've heard it's come a very long way in that time, especially after the funding injections it got during the mega Unity controversy. I just only type it, never say it. That's true. Yeah, I'll have like a OBS control, so I can just flash the word, on the screen when I need it. But okay. Yeah, if you have questions or you want to see some stuff, or if you're like, hey, what would happen if you put this in like this, or just any random questions really, I will be around. So just send them into the Discord. and we will have a look at it, and I'll answer it, and I'll happily get into some conversations. Yeah, do that, and I will catch it. Where is it? Here we go. Our Discord. If you're not in it already, come and say hi. Plonk. There's some links. Otherwise, I think I'll leave you guys here. I hope you've enjoyed this kind of little tutorial and stuff. But I'm super hungry and I haven't eaten yet, so no games today. But maybe games soon. If people want games, I could play games. So yeah, see you later.